refers to the set of assumptions a learning algorithm makes to generalize from observed data to unseen instances. These biases guide the model's learning process and affect its performance of the new data. What is hypothesis space? Hypothesis space जो है वो एक सेट है all possible functions or models का that a learning algorithm can choose क्योंकि एक learning algorithm choose कर सकती है based on assumptions training data. तो जितने भी possible functions हैं जो कि model that or models that learning algorithm can choose from based on the assumption and the training data. It defines the scope within which the model searches for best fitting function. ठीक है, हाइपोथेसिस स्पेस ये नहीं है। अभी अपन क्या सोचते हैं, हाइपोथेसिस स्पेस एक सेट ऑफ फंक्शन है, लेकिन ये पॉसिबल सेट ऑफ फंक्शंस या मॉडल्स दोनों को मिला के होता है that a learning algorithm can choose from based on its assumptions and the training data. It defines the scope within which the model searches for best fitting function. वेक्टर स्पेस, व्हाट इज अ वेक्टर स्पेस? वेक्टर स्पेस जो है एक मैथमेटिकल स्ट्रक्चर है जो कि वेक्टर्स के कलेक्शन से बना है जिसमें एडिशन मल्टीप्लिकेशन स्केलर के साथ और कुछ प्रॉपर्टीज को सेटिस्फाई करते हुए सच एज एसोसिएटिविटी कम्यूटिविटी एंड डिस्ट्रीब्यूटिविटी। तो एसोसिएटिविटी क्या होता है? एसोसिएटिविटी होता है ए प्लस बी इज इक्वल्स टू बी प्लस ए। This is associativity. If we call what is commutativity, so like if A plus B plus C is like this, then it is also like this. This is what? This is commutativity. And what is distributivity? Distributivity is like A into B plus C. This is equals to AB plus AC. This is distributivity. Now we will talk about the span. Span क्या होता है? Span एक set of vectors है जो कि जिसके जिसके लीनियर कॉम्बिनेशन से उन वेक्टर्स के लीनियर कॉम्बिनेशन से इट रिप्रेजेंट्स बनता है इट रिप्रेजेंट्स subspace of a vector space that can be reached using these vectors. It represents the subspace of the vector space that can be reached using those vectors. What is singular matrix? Singular matrix is a square matrix that does not have any inverse. This happens when its determinant is zero, meaning rows and columns are linearly dependent. What is the norm? Norm of a vector is a measure of its length or a magnitude in the vector space. Common norms include Euclidean norm, Manhattan norm. What is Euclidean norm? Euclidean norm is simply x1 plus x2 plus x3. This is Euclidean norm. Now comes the random variable. What is a random variable? So random variable is a numerical value assigned to outcomes of a random variable, random experiment. So let's suppose we have head and tail, heads and tail. If we define head as 1 and tail as 0, then we are representing this outcome in the form of a number. Okay, a numerical value is assigned to this outcome. Okay, so this can be for discrete or it can be for continuous variable as well, where infinite range of values can be seen. Now comes the marginal probability. Marginal probability is the probability of a single event occurring regardless of other variables. It is obtained by summing or integrating over the probabilities of related events in the joint distribution. What is discriminative model? Discriminative model is a type of machine learning model that directly maps input features to output labels by labeling decision boundary between classes. Examples include logistic regression, support vector machines. All these are the examples. Now we'll see what is the difference between the supervised learning and unsupervised learning. Okay, so we have to explain it with the help of examples. So now we'll see. So now supervised supervised learning and unsupervised learning are two main types of machine learning approaches. Supervised learning In supervised learning, the model the model the model is trained using labeled data, meaning the input data comes with corresponding correct outputs. The algorithm learns the relationship between inputs and outputs to make predictions on the new data. Example, like we have the example of a spam filtering classifier, which is spam email classifier, which is trained on the emails labeled as spam and not spam. So to predict whether a new email is spam, we can classify it based on the labels that we have given depending on the features of that particular email. Unsupervised learning. So in unsupervised learning, the model is trained using unlabeled data, meaning the algorithm is itself identifies the patterns and the structures in the data without predefined categories. The algorithm doesn't know any such category, but it itself learns and identifies the patterns in such a way that it is able to classify them. So it mainly uses the clustering and association tasks. Some examples are like the customer segmentation model. The customer segmentation model groups customers based on their purchasing behavior without predefined labels. Now comes the question, is artificial intelligence being same as human intelligence? Explain how AI utilizes different approaches for understanding of the real world. Now comes, what is AI? AI is not as same as human intelligence. While AI can perform tasks that require human-like intelligence, it lacks consciousness, emotions, and true understanding. AI is based on algorithms and data-driven learning, whereas human intelligence involves reasoning, creativity, and adaptability beyond data. How AI utilizes different approaches to understand the real world. So like ML, machine learning. AI learns from past data and improves decision making such as spam filters or recommendation system. Now comes the deep learning. So AI mimics human neural networks to recognize patterns in the images, speech and text such as self-driving cars or virtual assistants. Natural language processing (NLP). AI understands and processes human language for applications like chatbots, translation services, etc. Now comes the computer vision. AI interprets visual data used in medical imaging, facial recognition, and object detection. Knowledge representation and reasoning. AI stores and processes structured information, helping in expert systems like medical diagnosis tools. While excels in speed, accuracy, and data processing, it lacks general intelligence and emotional understanding like humans. So now comes the question. What is overfitting and what is underfitting models and how to avoid them? So what is overfitting? So overfitting occurs when a model learns the noise and details of the training data too well, making it perform poorly on new and unseen data. The model becomes too complex, capturing patterns that do not generalize. So how to avoid it? So the way to avoid is use more training data, apply regularization techniques, use cross validation, prune the decision trees to reduce the model complexity. What is underfitting? So underfitting occurs when a model is too simple and fails to capture the underlying pattern in the data. So like if we have an example, let me show you an example. Like this is the data. This is X, this is Y. So this is some data. So if the model tries to learn, this is underfitting. And if we see some other option, this is like this. This is overfitting. This is overfitting. And this is blue one is underfitting. So overfitting and underfitting. So these are the examples. So in this one, if we see in this pattern, the model is trying to learn the exact pattern of the data, which we do not want because we want to generalize. If we were to get some other input, then the model should be able to classify it. Maybe it will move in some other direction. But if we see this one, this is very far away. So it is both are not good for our prediction. But if we fit the pattern, if we fit in such a way, then it might be possible that we will get a better approximate idea of this particular node. So the model performs poorly on both training and test data. So how can we avoid it? We can avoid it by use of a more complex model. Complex model we can use and we can we can avoid the underfitting and overfitting. We can increase the number of features. We can increase the number of features. We can reduce the regression spans. The key is to find the balance between complexity and generalization to achieve the best performance. Now here we are given a vector. A 2D vector space was rotated by 45 degrees in clockwise direction, followed by shearing in x direction by 45 degrees. How a vector 14, 15 transpose will transform under those transformations. So we get the rotation matrix by the use of the following concept. So I will explain this concept first, then we will move on to this. So suppose we have a rectangle and we want to rotate it. So this theta, so it will result the x, this becomes y cos theta, this becomes sine theta, and all these things. So this way this matrix is obtained. And with the help of this matrix we get this matrix. by simply putting in the values of sine 45 minus 45 sine cos 45 sine minus 45 cos minus 45. We can get those. Now we have the given vector 14, 15. Applying the rotation. So now we will multiply this vector, this matrix, by the vector and get the transformed vector. And we need to know the shear matrix in the x direction with the shear factor of tan 45 because we are doing shear as well. For this shear we have this matrix which is 1 from 1 1 0 1. This matrix, this one represents the shearing. Okay, and simply we multiply this with the vector that we get previously, and then given the multiplication of the vectors, matrices, and we get this answer. Now we need to check if the following is a valid linear transform. So we can see this t of x y is equals to 3x minus y upon and x. So this is some sort of transformation. We apply the transformation t on this particular vector or matrix, whatever we say. So we apply a transformation of this in this matrix, and this transformation turns this vector, this matrix into this matrix. This is we have to check if this is a linear transform. So for the linear transform to happen, so the transformation should follow this property. V plus W is equals to T of V plus T of W. This property it must satisfy. And the second property is T of CV is equals to C times T of V. If these two properties are satisfied, then only we can say that this is a linear transformation. So, if we see the additivity and homogeneity, so let us consider V as x1, y1, W as x2, y2, and then simply we put on these values and we try to plug in the values wherever there is x, we replace it with x plus x2, x1 plus x2, and wherever there is y, we replace it with by y1 plus y2. So as you can see in this also. So this is replaced by y1 plus y2, this is x1 plus x2, this is y1 plus y2, this is x1 plus x2. So in this way we transform. And we try to split this. So we try to split if we get T of V plus T of W. So we try to split and we just multiply inside and we get this particular expression. This is looking like T of V clearly because V is what? V is x1, y1. So x1, y1, so we put this and we get this. So this is clearly the T of V. And similarly, this is nothing but T of W. So now we can say that this property is satisfied. So the additivity property is satisfied. But still, we need to know that there are two conditions. One is additivity, second one is homogeneity. We have satisfied the expression with additivity. Then we want to check for homogeneity. If it applies for homogeneity as well, we will consider it as a linear transformation. So now we will see homogeneity. We just multiply a constant c with the v and we try to plug in the values inside the transformation, and then we try to revert back and try to take common c, and we get c times t of v, which is the condition for the second condition for homogeneity, means the second condition of homogeneity. So this is also satisfied. means A is a valid linear transform. That implies that this this vector, this T is a linear transform. This T is a linear transform. That's what we get. Now we will move on to the second part. So second part we have T of x from xy is equals to x mod upon and y. So now if we want to find the T of v plus w, we get this, and we try to put in the values inside, and we try to split it up, we get something we can observe here, that T of v plus T of vw is equals to this, which is not equal to this. This, if we compare this with this, you can see there is no matching, because we know that x1 plus x2 mod is not equal to x1 mod plus x2 mod in general. So this implies that additivity fails. If additivity fails, we are sure that it is not a linear transform, because there are two conditions and both the conditions should be satisfied. So we have satisfied, we do not satisfy the first condition. So we can clearly say that our transformation is not linear. So we also need not to check the associative that homogeneity property, but still if we want to check, we can see, can clearly see, we multiply the c constant in it, and then we take out the multiplication and all, and we try to merge it and find the c. When c is constant, c is come out, c is multiplied inside, this thing is not equal to this thing. You can clearly see that. So the homogeneity also fails, and which is not valid, implies which is not a valid linear transformation. Now we'll check another matrix, another vector for linear transformation. So we want to check the additivity. We simply do this T of v plus w and simply put in the values of x as x1 plus x2, y as y1 plus y2, and similarly in this. Then we find this, so we implement it, we put in the values, and we see and then we compare both of these. If we compare, this thing is correct, this thing is also correct, but this thing is not same as this. So this thing is not same as this, it means additivity fails. Additivity fails. Since additivity fails, we need not to check that linear what do you call homogeneity property. We need not to check. Now comes the D part. So we have T of xy is equals to 2x1 to 2x plus 1, x minus 2y, and y. We just need to check for additivity first. So we just put in the values, we put in the values inside, then we try to find the values of this, we put in the values, and then we see. And still we can see both, we compare both of them, we do not see any similarity. But so that's why we can clearly say that here also additivity is failed. So since the additivity fails, D is not a linear transformation.